Hello, I'm James Kilgo with the South Carolina Rural Water Association, and I'm here at Generator Services Inc. And I would like to introduce to you all for this presentation Justin and Dylan. Justin, can you introduce yourself?
Yes, I'm Justin Bellers with Generator Services. I'm a service writer as well as a technician here at Generator Services. So I do a lot of the scheduling for the technicians and assist in the field when necessary.
Yeah, and I'm Dylan. So I'm in the sales department, kind of the engineering department as well. So yeah. All right, so we're over here at the generator now. This is a Blue Star Power Systems 40 kW. It's a John Deere generator or engine with a Marathon generator end. I guess starting off, now that this thing's open for weekly inspections, what we're looking for is to make sure this thing's got no faults, and we want to make sure that it's turned off before we do any inspections.
Yeah, so like Dylan said, as you're coming up to do your weekly test, the first thing that you want to do is look at your control panel to see if you have any kind of fault lights active. That will be indicated by a red light here next to the alarm. We don't have any of that present. If you do, it's always good to make a note of the fault light so that you know for the service technician what has happened with that unit. So again, walk up to it, see if you have any kind of fault lights. We don't here. We're going to switch this unit to off for the safety of doing the maintenance. You have to remember on these units that they will crank and run at any time, so disabling it before you do your checks is always the best idea. That can be done by pushing the off button, and we've got the alarm silent so that we don't have to listen to it while we're doing our maintenance. So that properly disables it so that we're safe to do our weekly checks.
All right, and then I guess furthermore, we're looking for any, we're going to do a visual inspection of this thing. We're looking for any rodents, any, dirt daubers, any wasps. You might want to have some bee spray with you, some wasp spray. Looking for any nests, any trash, anything that could get in our way when this generator was to run. So I guess maybe point out some places that would be typical for a leak. Maybe, I know a dirt dauber may want to be here in the fan. Just where kind of would you see a rodent or a potential leak of some kind?
Yeah, so now that you've walked up to the unit, it is being out in the elements the way these are. We do see the squirrels build nests in them, birds build nests in them, the wasps, the dirt daubers, all will make this their home. So you want to be aware of what's going on in here. Open up all the doors, kind of walk around and check. Look to see if you've got any kind of nest or anything around it. Look to see if you have any wasp in here. All that stuff can get sucked up into the fan. So you do want to try and keep this as clean as possible. We don't really have any animals living in this one, but you do see it. So be aware that that can happen at any time.
All right, and then I guess for our weekly inspection, we also want to check our fluids. I guess starting off, we want to check our coolant.
Yes, so coolant is an important part of this. You want to make sure that you have adequate coolant in the unit. I'm going to climb up here so we can see the radiator cap and kind of look at that. But what you would do is take the radiator cap off, check the coolant level, and make sure the coolant is 100%. Be careful when you're taking the cap off. It can be hot and under pressure, so just be mindful when you take that radiator cap off that you don't burn yourself or hurt yourself. Once you take the cap off, you want to make sure coolant is filled to the very top. This particular unit has a low water level sensor, so the coolant level has to be over the top of this sensor. So we always tell people fill it to 100% and make sure that it's as full as it can be.
All right, I guess going along with our fluids, we want to make sure we got some fuel. I know on this side with this 2020 controller we have, we can check fuel by looking at the screen there. I guess could you demonstrate how we're going to check fuel, and then we'll move on to the other side and check fuel as well.
Yeah, so diesel fuel, we've got to have enough in it to run the station for any length of time, so you always want to make sure you keep an adequate fuel supply in it. We've got a gauge on this one, so if you look at the screen here, you do see that the fuel level is at 72%. That is a nice feature to have, is that your controller shows your fuel level. Don't always have that. We've got a mechanical gauge here on the other side that we can show you how to check the fuel level if you don't have one on the display. So we'll walk around to the other side here and take a look at the fuel level on that side. Again, with this, we've looked at the digital display. We do know that we have good fuel supply in here, but if you don't have that feature, there's a mechanical gauge on all the fuel tanks that will give you the same reading. So you just have to be mindful of your equipment as to what areas you're looking at to get those particular readings. We checked it there, but we can double check it here and make sure that it's adequate.
And I guess going along with our fluids, we want to check our oil as well. I see our dipstick there. I guess run us through what we're looking for when we check our oil in this unit.
Just like coolant, we want to make sure the oil is full as well. So what we'll do is make sure the unit hasn't run recently and that all the oil's down in the bottom of the pan. We'll pull the dipstick here and check and make sure that the oil is at the correct level. If you see there, you've got an add mark. Our oil level is above that in the cross-hatched area, so we know that we've got the adequate oil level. While you're looking at the level, you kind of want to check the condition as well. So we see that this is a nice honey color. It hasn't turned soot black, doesn't have any kind of sediment or contaminant in there. So just look at the oil level as well. Make sure oil level and condition while you're doing it to make sure you don't see anything that stands out. If you have to add oil, just consult the manufacturer's recommendations for the type of oil that needs to be put in the unit.
All right. Another thing we're going to inspect is belts and hoses. This seems like a good location for us to check those out. What kind of information can you give me on a visual inspection of those?
Okay, so on this side we've got the hoses here. We've got block heater hoses, and we're showing our lower radiator hose. Upper radiator hose on the other side will be checked in the same manner, but we'll just do it on these for the time being. Want to look around the base of the hoses where they meet the pipes. Make sure you don't have any coolant leak or any kind of crust building up that indicates that fluid has been leaking out. So we want to see if we've got any leaks around the hoses themselves, and then check the condition of them. All of these look good. We don't have any leaks around it, but you want to kind of squeeze the hose, make sure it hasn't gotten too soft. It has soft spots in it and feels like it's going to fail. It does need to be pliable though, so the hose shouldn't be stiff, but it also shouldn't have soft spots in it. Pay close attention to this upper block heater hose because this is the most susceptible to failure. This is where all the heat's transferred from that heater, and that tends to be the hose that breaks down first. So be especially careful with your block heater outlet hose. Make sure you don't have any problems with that.
All right, I guess we're going to move back to the other side. We'll check out our battery and our air filter.
Okay. All right, so
I guess you're going to need a flashlight for this one. The easiest way for you to check your air filter, here you go.
So air filter up top, as Dylan was saying, that is a key component to this. We want to make sure that it's not obstructed, that it's not starting to get clogged up. So this one is this filter is not a removable element. You just have the whole filter itself. So you have some windows at the bottom here you can look in to see if you've had any dirt daubers build nest, if you've had any kind of bags that have sucked up in there or trash, and also make sure there's not a lot of dirt and debris on that filter. So what we're going to do is just kind of shine a light up in here and look all around the filter and make sure that we don't have any kind of problems with that filter. This particular one looks clean, so I think we're going to be good to go on that one. Especially with these generators, because they don't run so much, those air filters don't tend to get as dirty. Usually moisture contamination gets them before anything else. Dylan, thank you, and we'll give that back to you.
All right. I guess next thing we want to check is our battery and our trickle charger, looking for any corrosion there. I guess walk us through the main things we need to look at for the battery and trickle charger.
So we've got our standard 12 volt battery here. This one is a 12 volt system. Two things we want to kind of look for on the battery itself is we want to make sure we don't see any corrosion or leaks around it. No kind of water settled on the battery that shows where acid's been leaking out. Also want to make sure that there's no corrosion on the terminals, both the positive and the negative. Don't see any corrosion on these, so they look good from that standpoint. While you're there, it's always good to kind of grab the terminal and try and twist it. Make sure that it's tight on that battery. A loose connection on that terminal can give a lot of trouble with starting this unit. So terminals look good, they're nice and clean, and they are tight. Everything looks good from that standpoint on the battery. You mentioned the charger, Dylan. All right, so we want to check and make sure this battery charger is working properly. We've got a couple of options on this unit. This one does have a readout on the screen for the battery voltage. So looking up here at the battery, we're seeing 13 volts. Again, this being a 12 volt system, we're at 13 volts. We know that charger is maintaining the voltage. The charger always wants to keep it at 100%, so this is ready to crank when you need to. Can look a little bit further on the charger. If you look here on the side of the unit, this is our battery charger. It's got some indicator lights on it as well. Green light meaning that the battery is charged and ready. Red flashing tells you that it's actively charging. So look for some lights on the charger. Make sure you do have either a red or a green light on it, and then see that your battery voltage is above that 12 volts.
Perfect. I guess we've got two more things to check out. We'll check out the breaker and the block heater on the back side, and that'll wrap up our weekly inspection here.
All right.
So now we're back here on the back side of the generator. We got our block heater here. I guess give us some information on that, Justin.
Okay, so as we looked at earlier, we looked at this upper block heater hose when we were talking about hoses and leaks. We also want to pay close attention to the heater. This heater is here to keep the engine at operating temperature, somewhere between 80 and 120 degrees at all times. It does that so that on a diesel unit especially, it helps with cold starts. A lot of these diesels don't like to start when it's cold. Keeping that engine warmer helps it crank in these cold conditions or in cold conditions. It also helps with premature wear on the engine. When these generators crank and go, they crank at a high rate of speed, and they're asked to do a lot of work right away. So this helps with premature wear by keeping that engine to temperature. Good way to check the block heater. You can touch it and make sure that it is warm to the touch. And also you can, a lot of times you can hear it when it's heating. You can hear kind of a gurgling sound coming through that, or coming from that heater. Works just like a hot water heater, so it just heats the coolant in this engine. Hot coolant rises into it and transfers heat through it. So want to feel the hose, make sure that that hose is warm to the touch, indicate that that heater has been heating.
All right, I guess in our last thing here for our pre-start inspection, we're looking at this 150 amp breaker right behind you. I guess run us through what we're looking for before we start this thing.
Okay, so one thing we do need to check is the circuit breaker. If this breaker is off or tripped, you're not going to get power from your generator to the facility. So we want to make sure that breaker is on, not in a trip condition, so that when we do run the unit, we have the ability to power the facility. Looking at this one, it is in the on position. It's not tripped, so we know that when we crank the generator, we'll get voltage out to our transfer switch and can utilize it. So everything looks good with the block heater and the breaker.
All right, Justin, well that pretty much concludes our pre-start inspection. Appreciate your expertise, and I guess in the next portion of this video, we'll talk about the actually running the generator and what we need to check while this thing's running for our weekly test. So now we're moving on to our running inspection. We've done our pre-start inspection, making sure everything is clear from the unit. One thing we will mention, you want to have PPE for this. You want to have some safety glasses. You want to save your ears with some hearing protection. We're not going to be able to run this unit for the purpose of teaching you guys. You're going to have to be able to hear us. So I guess moving into this, I guess how would we get the unit started, Justin?
So yeah, we've completed step one. We've done all our pre-start checks, so now it's time to crank the unit. We're going to crank this from an offline test standpoint. So not going to interrupt any power to the facility or to the building, but we are going to run it to make sure everything's working properly. We've already got the unit switched off, so we've got it switched off from earlier because we wanted to make sure it was safe while we checked it. What we need to do to run it is we're going to hit that run button and crank the unit. This will crank it and run it in depth for as long as you leave it in that position, and we are going to get further into that once we kind of go through what to look at while it's running. So we'll run it at the end of this, just not going to do it right now while we're kind of explaining everything.
Okay. So just for the purpose of this video, we're pretending like this thing's running. I guess how are we going to check the AC voltage on this thing? I know we're 240 at this site. And what kind of variance are we looking for? What would be the value we're looking for as far as voltage is concerned?
So this is a 240 volt facility. You have the option on this controller to look at the voltage, amperage, what phase it's reading at, and the frequency with it's running up here. So the screen will get, or the digital display will give us our best reading for voltage. So once it cranks and runs, we're expecting to see 240 volts on this side, plus or minus 5 to 10%. You have a little bit of variance, so it can be off by a little bit, but we'll say 5 or 10% at the most. Good rule of thumb, you always want your generator voltage to match your utility voltage. So if you've got 242, let's set the generator voltage to that same 242.
I guess it's frequency as well. So you're going to have some variance in that. What kind of variance could we expect, and what frequency are we looking for?
Yeah, so frequency will be read as well on the controller. It's supposed to be right at 60 hertz or 60 cycles per second. You're looking somewhere between 58 and 62 hertz. If you get into that 65 hertz range, it's going to be shutting down. Anything below the 55 or so, and it's not running fast enough to power. So looking for 58 to 62, and again, we'll see that once we crank this unit up here in just a little bit.
Okay. And then running temperature, what variance are we looking for there? What would be an average running temperature? I know you're going to have to refer back to your manual specific per unit, but what would be general rule of thumb? What are we looking for temperature wise?
Okay, so on the temperature side, this being a diesel unit, it's going to run a little bit cooler than most of our gas units, either propane or natural gas. On this diesel, we expect it to be somewhere between 160 and 180 degrees while operating. Gas unit might be a little bit higher. They might touch into the 200 range when they're operating. But yeah, we're looking for about 140 to 160, or excuse me, 160 to 180 on this one. We do have that same readout on the screen. We're seeing now that it's at 115 degrees. That's based off our block heater operating. Know it's at temperature ready to crank. So see it somewhere in that range when we get it running.
And I guess I did forget to mention, we're going to want to let this thing to run for about 10 minutes before we start taking these readings, isn't that correct?
Correct. It's going to take a minute for it to come up to operating temperature. So once we initiate this offline test and we're going to go get our readings, give it about 5 or 10 minutes to let it come up to temperature before you see where it stands.
And when we're checking our oil pressure here as well, as the unit comes to running temperature, that value is going to go down, right? We're going to have a lower PSI rating, maybe around 40 or something along those lines?
Yeah, correct. So we've looked at voltage, we've looked at frequency, talking about coolant temperature. So oil pressure also is crucial when this thing's running. You do want to kind of check and see what the oil pressure is. We expect it to be somewhere between 40 and 60 PSI. You have to consult the owner's manual because all of them are a little bit different. Oil pressure reading will be right here on the display as well, and we'll see that once we crank the unit up.
And then I guess going to our battery, there's a 12 volt and a 24 volt system. What kind of variance, what kind of reading are we looking for there? Could you give us any information on that?
Yeah, so this one being a 12 volt system, we're looking for that battery voltage to be somewhere between 12.5 and 14.5 volts. As the unit's running and the alternator's charging, you're going to see it a little bit higher, so in that 14.5 range, but somewhere in that vicinity with a 12 volt system. Some of the bigger units do have a 24 volt system. In that 24 volt system, you're looking for the battery voltage to be somewhere between 25 and 28 volts while operating. So also you can see all that on the screen, or if you have to, you can put a voltmeter on the battery or batteries to check that. But 12.5 to 15, or 12.5 to 14.5 for a 12 volt system, and 25 to 28 on the 24 volt system.
Okay. And I guess as you go to start this thing, you're going to show them how to start it. I'm going to get out of your way. You're going to put some PPE on. You want some glasses and some hearing protection. Also, I guess maybe explain the cool down before this, since we're going to start it. That'll kind of end our video. We want to make sure that this unit is able to cool down after it's run as well. We don't want to just bash the e-stop button. So, like I said, I'm going to get out your way. I guess run through those for me.
Okay. So yeah, we are. In just a second, we're going to crank this thing up in the off position, or in the offline test position. Let it run for a little bit, like we said, about 10 minutes to get it up to operating temperature and take our readings. When you do a loaded test and you actually transfer the building over, then you want to make sure you do a 5-minute cool down timer once it transfers back. We'll get into that a little bit more when we go over to the transfer switch portion of this, but for now we're just going to do our offline test. I'm going to crank it up in the manual position, let it run for a little bit, and we'll zoom in and kind of look at some of these readings to see. So I'm going to grab my safety glasses and my ear protection, and we're going to crank this thing up offline and see how it does. Again, first thing, we've already got it to the off position, so what we're going to do is we're going to hit this run button. That's going to crank it up. All you have to do is hit the run button one time. It will crank and run. Don't have to hold it or anything of that nature, just that one touch will do. So let me put this in and we'll crank it up.
So that's running. I guess we do need to talk about the cool down. Typically you won't want to let it just shut it off like this after it's run a test. You want to allow it to cool down on its own. So I guess Justin, if you could run that down.
Yeah, so we cranked it up in the off, or in the run position for an offline test. Ideally, you'll let it run for about 10 or 15 minutes a week when you're doing these checks. While it's running, you'll go in here and check your oil pressure, coolant temperature, battery voltage, all the things we talked about earlier. So while it's running, once it's reached operating temperature, kind of take a note on those readings, and then you can switch it back off with the off button when you're done. Again, we will switch it back to off. We've done that to shut the unit back down, and we're going to put it in the automatic position so that it's ready to do an online test here in a minute. When we get into that online test, we'll get to see it transfer over to the building, retransfer back off the generator, and we'll go into a cool down state with a loaded run. So we'll get into that on the transfer switch portion. But at this point in time, we've gone through all of our readings on the generator. One thing we didn't talk about earlier is the engine hour meter. All these do record the amount of hours they're run, so that's how you can track how long you've run it for the test. Always keep a note on that hour meter, because that'll let you know if it's been running weekly or not.
Well, I appreciate the expertise. We're back in auto. I guess we'll move back to our transfer switch back here behind the building. All right, we're back here with the transfer switch. This is an ASCO 300G. It's a 400 amp transfer switch. One thing we'll ask is probably don't go behind this door. You're going to definitely need some other equipment for that. You want to stay safe. Behind you, you could potentially get shocked or have arc flash, something along those lines. So for a weekly test that we're kind of asking our customers to do would be in front of this door, just looking at the screen here. So I guess, Justin, what is the first thing we're going to do? We're going to open up this door. We're looking for any faults similar to the generator. What would indicate a fault on this switch here?
Yeah, so we walked up to the transfer switch. We've got our first door open, which is just our weatherproof cover. And like Dylan said, we're protected because we've got this door here closed, keep us from any electrical shock or arc flash. So just like the generator, when we walked up to it, you want to kind of note the state of it when you get there. It does, as Dylan pointed out, have fault lights just like your generator controller does. So walking up to this, the first thing we're going to look at is for these lights in the upper right-hand corner. That will indicate a fault with the transfer switch. If you have a red or an orange light here, that lets you know that there is a problem with it. It's also going to prompt you to the screen to let you know what that problem is. So you'll see a light on top of this showing there's a fault, and then it'll display what that fault is or what happened to set it on the controller screen itself.
Okay. And I know this is this means utility power, and this is our generator power. I guess explain what these lights mean as well.
Yeah, so just like the fault lights, the switch position and available lights are just as important. Over here on the left, we have our normal power lights. So far left here, saying that normal power is available to the facility. The next light in lets you know that normal power is connected. So when you've got two green lights going, you have normal power available, and your facility is running on that normal or utility power.
And I guess, so we're going to test this thing. The other lights, you want me to talk about these two? All right, so the generator side, I guess, what are these lights going to do?
We saw the normal side lights. We've got two that aren't lit up here on the right. Those are the emergency side lights. These are only going to be operating when the generator is running or when the transfer switch is in that emergency position. So we don't have anything running right now. We will a little bit later on. But same as the utility lights, the emergencies reference what's happening with the generator. The far right light being on and red lets you know the generator is running, and one end will let you know the transfer switch is switched to that emergency position. So the fault lights will or the indicator lights will let you know what's going on with the switch as you walk up to it.
All right, I guess moving on to the actual test. I know when we ran the generator test, it was just the generator running. Now we're actually going to run generator power to the building. So I guess I know there's two ways you can flip this breaker here or push the test button. I guess walk us through what we're going to do to test this thing. I know we do need to make sure that everybody inside is aware, no critical documents. You know, for example, we have a server room. In the case that blip would cause a problem there, we want to make sure everybody is aware of the transfer test that's about to occur. But I guess, Justin, walk us through how we're going to make that happen.
Yeah, so we've got two options for testing this switch online. We've tested the generator offline, but now we're here to power the building with the generator to make sure everything's working properly. One option you have here is to turn power off, and that's just your service disconnect breaker to the ATS. This will cut power off to the facility and force the generator into a test position. That's an option, but that is turning power off to your facility. So like Dylan said, you want to make sure everybody's aware of what's going on and you don't put people in the dark before they know it. Second option, which is a little less invasive, is the test button here. This is just going to switch the switch over after starting the generator, but you don't get that power outage during it. So quick blink by doing the test button, or you get an extended turn-off when you actually kill power to the facility. For this purpose, we're going to test it through the test button and see how it works from there.
And I guess before we do that, what are we going to expect? I know we're going to hear a clicking noise in here with the transfer switch actually initiating that transfer, and then we're going to hear the generator crank up on the other side of the building over there. I guess what do we expect seeing lights change? What are we looking for?
Yeah, so we're going to initiate test, go into a loaded test, so we are going to see some lights change. You want to make sure, just like we did before, that there's no one around the generator. The generator's clear, so I always want to make sure that it's free and clear before you start it. What we'll expect to see is we'll initiate the test by pushing the button. Once we do that, we'll have to enter our password in it. Password's available to everybody from that standpoint, so if you need it, you can get it. But we'll enter the password, start a test. The first thing we'll see is we'll see a red light on the right-hand side come on, showing that the generator power is available and acceptable. Secondly, when the transfer switch transfers, this green light on the left will go out, this red one will come on, indicating that the switch has changed state and is now powered on emergency. Like Dylan said before, when you start this and push the button, you'll hear the start relay close. When the transfer switch transfers, you will hear a loud clunk or thud behind here. So just be on the lookout. It gets you every time, but you will hear that transfer over and then indicate it with the lights.
I guess one more question, maybe two. When you go ahead and test this thing, you're going to want to check the frequency and the voltage again, which is available to you on this screen, correct?
Yes. Yeah, so while it's running, we checked all the generator stuff out there at the control panel. We want to check output voltage and utility voltage here at the transfer switch. On this particular model, it can be done by hitting the down arrow, which brings you a screen up to show you your readings. We show to have normal power and frequency is correct. Emergency is not available, but we don't have the generator running yet. So when we crank it up and run it, we will kind of refer back to this screen just so we can look at the voltages we're doing.
How long are we going to run this test for?
So this test is set up for 10 minutes. It is adjustable. We recommend at least running it 10 or 15 minutes under load. Again, we're just going to do it for 10 minutes for what we're doing here, but that will be indicated on the screen. So once we initiate it, it'll be 10 minutes running the building, and then that cool down timer you talked about, a 5-minute cool down timer afterwards. So that just helps the generator cool back down before it shuts off. It doesn't shut off too hot.
Well, I guess if you don't have any other information you need to share with us, we'll go ahead and demonstrate that test. And I guess if we could have the camera come up and just kind of display what we've got going on up here, I think that's all
right. Well, yeah. We've let everybody know that we're going to interrupt power here at the facility. So we'll start with this test and put it in and see how everything works out. So first thing we're going to do is hit our transfer test button. It's telling us to enter the password, which in this situation is all ones. Again, each manufacturer is different, and that is available in your service manual. So now we've entered the password and we are starting our test. I can hear it in the background, the generator started. We do have a red light saying the generator's available, and there's that clunk we were talking about earlier. We are on generator power. So notice that your green light here went out and you went to a red on this side that's showing generator available and connected to emergency. So our facility is running on generator. Dylan, what are a couple of things we need to do now that we're running on generator to verify everything's working properly?
So I guess at this point, you may want to go inside, make sure, for us, the server is is powered. We have lights on, possibly the air conditioner's running. Basically anything that is on generator power, we want to verify is working at this point in time. So yeah, I think that's pretty much where we're at. Things testing. We want to make sure the thing cools down. I guess just sit here and wait the 10 minutes, and then we'll go ahead and shut that thing off unless you want to go ahead and turn it off now.
Yeah, so while you're running on generator, like he expressed, you want to make sure everything of your facility is working. Now's the time for you to start your pumps, check the pump motors, make sure that your building or facility operates as it did on normal power. We've walked through it, we talked to everybody in the office. We know that everything's fine in there. The air conditioner's running, the server's good, got lights, so we're happy with that. You have the option of letting this thing run for that full test, which as you can see here, we've got another roughly 8.5 minutes to run. We're not going to wait that time, or if you have something come up and you want to bypass it, you have that ability. So just like we did with starting the test, we can end the test by hitting the bypass timer button. But we're going to do that just to switch it back over and shorten this up a little bit. So I'm going to hit the bypass timer. As you can tell, you heard the switch transfer back. We now have 2 green lights letting you know that our building is running off utility power. 1 red light saying that the generator's still running. This is that cool down. It's expressed on the screen, normal's okay, and engine cool down at roughly 5 minutes. So you can't bypass that cool down timer, so we're gonna let it run for the 5 minutes and cool back down.